Is this actually working for easy now? Okay, it is now. Nice. Here we go from there. How do I add buttons? Whatever I'll just go with this. My audio fine. Test. Okay, it should be fine. Alright, now I'm gonna do this paper to completion, then mark it, then do paper 2, and if I have time I'll do another different paper. So yeah. Yippee! Tensile gauge, ounces per inch. PSI unit is an example of imperial unit. Pounds and inch, imperial. Each of these is a scalar quantity, the amount of heat. Amount is scalar, while acceleration, force and momentum all have a direction, it's a vector unit. Example shows an arrangement of apparatus to study the relationship between extension of a spring and force. Each of these inference is correct. The higher the force, the higher extension of spring. I think. Actually, for inference, I think it should be the because it's inference. This is for hypothesis, I think. This is just wrong. I think this is for relation or observation, I think maybe. which of the following is true regarding the motion of a car with zero acceleration? Minimum velocity, no. Acceleration doesn't say anything about maximum or minimum velocity. Constant velocity, yes. Maximum velocity, no. It can go faster always if it's depth acceleration. Stationary, I mean, I guess, but the answer probably wants to be, but this is right as well technically. If you're stationary, you have zero velocity and you have zero acceleration. Diagram T shows a displacement time for the motion of an object in a straight line. Calculate the total displacement and distance traveled by the object. So displacement is zero because it comes back to its original spot. And distance 20, up and down 20, down and back up, 5 plus 5, 10, it should be 0, 30. Song's weight on the moon is 80 newtons. What will happen to his weight on the surface of the earth? If he's 80 newton on moon, higher newton on earth. Because the moon has a lower gravitational acceleration compared to earth. W equals mg. The gravitational force between two objects is directly proportional to the product of the masses of the two objects and inversely proportional to the square of the distance between the centers of the two objects. The above statement refers to Newton's universal law of gravitation. I'm gonna decrease the size of this a bit. The first law says that a planet's orbit is an ellipse with the sun on one of its focal points. The second law states that the area swept between a line that connects the sun and the planet goes through the same area within the same time span or something like that. I don't know in English. Kepler's third law is P squared is proportional to R cubed. Or more specifically, excuse me. The orbital radius of S1, which orbits in the period T, the value of the radius of satellite X2, which orbits in period T is so T squared over R cubed, T1 squared over R1 cubed equals T2 squared over R2 cubed, because T squared over R cubed is a constant, so we can say that for two systems this must be equal. T1 is where's my T squared over R cubed equals 8T squared over X cubed. cube root of 8 squared is 64 t squared, you know, t all squared over x cubed. So x equals the cube root of 64 t squared cube over t squared equal to the cube root of 64 r cube. Cube root of 64 that's more scientific because I don't memorize the cube roots. Cube root of 64 4. Oh, no, don't load it. Equal to 4r. Okay. Which of these is not true about geostationary satellites? Not true. This is not true because it's 24 hours. This is not true because, of course, it always has a gravitational pull, or else it wouldn't orbit. Orbit requires gravitational pull. This is true, I think, and this is true. So 2 and 4 only. During the day, it was found the sun on land was hotter compared to seawater. This phenomenon can be explained using concepts specific heat capacity. Land has a lower heat capacity than water, or more specifically seawater. If I'm not mistaken, it's around pure water is around 4.2 K. 4.2 kilojoules per kilogram Celsius. Land, I don't know how much it is. Diagram 4 shows the heating curve of a liquid. Statement shows the correct destination at BC. Latent heat is absorbed. Change of phase from liquid to gas. This would be cooling. So 1 and 2 only. Heat capacity is not absorbed. If heat capacity was absorbed, it would be experiencing temperature increase, but no difference. Diagram 5 shows a balloon which is placed in an airtight container. If the piston is moved from X to Y, what will happen to the balloon? The air inside will become high pressure, so it will contract. And the film is working, right? Yeah. Okay. Number 13. What happens when resonance occurs in an oscillating system? Frequency of oscillating system is equal to the natural frequency of the system. Okay. That's resonance. This, if it's not always sound waves, and even if it is sound waves, it usually is audible. Energy in the system reduces continuously. Maybe I think it happens to all systems, but not specifically because of resonance. And if there's no outside interference, it would uh, dampen. System stops oscillating immediately. I don't know. Diagram 6 shows the direction of propagation of a waterway from deep region to shallow region. From deep region to shallow region, I think it gets, I don't remember. I think the wave gets slower in shallow region. So I think it would be, but there's no towards normal line and wavelength decrease, so yeah, I assume it's up. Away from normal line and wait. Oh, oh there is. I'm stupid. There is here. It gets slower in shallow region. Monochromatic light with a wavelength of 5 to the negative 10, 5 to the negative 7, 5 times 10 to the negative 7 meters experiences interference after it propagating to plates. Its strength between two consecutive flux ranges is 1 times 10 to the negative 10 meters. Lambda equals AX over D. I think D equals AX over lambda. I don't remember this formula. Over, no, not here, 5 times 10 to the negative 7, 2000. No, that's definitely wrong. I genuinely don't remember which is A, which is X, and which is D. And the formula sheet doesn't say, it only says the formula. Okay. Um, Maybe it's X. Let's try. This will be 5 times 10 to the negative 10, and I don't know the formula, so I'm just gonna say yes. I don't remember what it stands for. I still need to revise that. After I finish this paper, I'll check. Okay, communications engineer wants to transmit a radio signal to a remote area surrounded by mountains, which is the most suitable to ensure signal reaches effectively. Radio waves because it has a high wavelength. I think the higher wavelength allows it to go through obstacles easily. I think, maybe, probably. Diagram 8 shows the spoon being placed in a glass containing water. Yeah, like it's refracted when passing through water. An object is placed in front of a convex lens with focal length S. An image of the same size of the object is formed on the screen, which of the following statement is true about the object distance. Object distance is something like this. Wait, it's in convex lens, yes. Image of the same size of the object. Oh, I understand. An image forms. How do I write this down? Here. Here. So I think it has to be greater than 2s. Right? I can't draw properly. If it was a proper exam, I would draw. I think it should be greater than 2s. Yeah. Each of the following characteristics of an image formed by a convex lens when the object is at infinity. Diminish inverted again. Student places a small object in front of a concave mirror and slowly moves it towards the focal point. The image changes from real to virtual and becomes increasingly magnified. Based on this observation, what is the real life application of this principle? Are there mirrors in supermarket aisles? I don't know. I think it's safety mirror. When an object has zero resultant force, the object is either stationary or moving with a uniform velocity. Why is my OBS like this? OBS. It's not too good. Okay. Okay. Something was wrong with my OBS. I don't know why. And I don't know how long it's been like that. So yeah. Okay. Moving on. Diagram 9 shows a lift moving upwards with a constant velocity. Which of the relationship of forces is correct? W equals R because it's at a constant velocity. No, no force other than W. Okay, next. Diagram 10 shows a box of mass 7 kilograms being put on a rough surface with a force. What's the acceleration of the box? So the net force equals 120 cosine 35 degrees minus 20. Excuse me. Cosine 35 1 times 20 78.29 newtons. 78.29 newtons. Over 7. Answer over 7. 11.185 11.19 meters per second squared. Ship is being towed by two identical moving boats. Which of the following diagrams produces the highest acceleration? Low angle produces higher acceleration. Yeah. Because less force is being used to counter each other's sideways force. Diagram 11 shows a container with different cross-sectional area and column shape. The container has been filled with a liquid and it reaches the height of h, which produces following and place the above equation. The liquid pressure does not depend on the column shape of the container. Does not depend. Because it specifically shows columns of different shapes. What happens to the gas pressure in the closed container when the gas temperature is increased? I think. So gas pressure increases. Yeah. Diagram 12 shows the airflow through a pipe at sections A and B, which have different diameters. What is the effect on air pressure at section B compared to section A according to English newspaper? The air at B is faster So the pressure at B is lower. Yeah. Diagram 13 shows two unlike charges and the point B located between them. Which of the following statements best describe the meaning of electric field strength at point B? Electric field strength is which formula? E equals F over Q. The force per unit charge exerted by an electric field at that point. I think this is voltage. Is it not? Work done. Yeah, E over Q, voltage. Or this potential difference depending on what you prefer. Diagram 14 shows the relationship between current voltage for two different types of conductors. Based on the graph, what is the main difference between conductor X and Y? Conductor X obeys Ohm's law, whereas conductor Y does not. Conductor X is an ohmic conductor, while conductor Y is a non-ohmic conductor. Diagram 15 shows two types of electric rice cookers. Rice cooker A has a power rating of 700 watts, 2 hours a day. Rice cooker B has a power rating of 500 watts, it is used for 3 hours a day. This is 1400 watt hours, and this is 1500 watt hours. So rice cooker B uses more electricity. Rice cooker A uses the least amount of electrical energy. Diagram 16 shows a simple DC motor with a commutator magnetic field from two common magnets and the conductor coil. What is the main principle that allows the coil to rotate when current flows through it? The magnetic force acts on the coil due to the interaction between the current and the magnetic field. Follows Fleming's left hand rule. Fleming's left hand rule. I think this way is the current, this way is the magnetic field. Therefore, I don't know the symbol. And this way is the force. Diagram 17 shows a bar magnet being moved into a solenoid, which is the correct direction of the induced current viewed from the left side of the solenoid. Viewed from the left side of what happened. Viewed from the left side, it will be from here. So when a magnet is being pushed to the solenoid counters it. This is south, this is north, so current flows this way. So when we view from the left side of the solenoid, it would be moving counterclockwise, anti-clockwise. It opposes the magnet like this because of Lenz's law. Diagram 18 shows part of internal structure of a transformer. This transformer experiences high energy loss when used continuously for a long period of time. What is the most effective step that can be taken to increase the efficiency of the transformer? Use a laminated iron core to reduce eddy currents. Diagram 19 shows a cathode ray tube used in a laboratory. What working principle enables cathode rays to be produced in this tube? What principle? Electrons are emitted from the cathode when it is heated and attracted towards the anode. Yeah. Diagram 20 shows a basic full wave rectification circuit using 4 diodes. What is the main function of the diodes in this circuit? It's to convert alternating current to direct current. Or in other words, as a rectifier. Yeah, as a rectifier. This is the function of the, what's it called? Yeah, capacitor. It says it right there. Capacitor. And these are irrelevant. What is the voltage across the LDR of the transistor? I think it should be over 5 times 9. Seven point two. 7.2 volts if I'm counting it properly. It's either 4K or up here or 1K, I don't remember. What is meant by half-life? Half-life is the time taken for the number of decaying nuclei to reduce by half. In a nucleus fusion reaction, a portion of the mass of the substances involved is converted into energy. What can be concluded about the energy released in the reaction? Energy release depends on mass defect produced. Yeah. And only be used in nuclear reactors? No. It can be used in the sun, well, and in a nuclear bomb, etc., etc. And this is no, and yeah, this is clearly not, because E equals mc squared, where m equals final m minus initial m. Diagram 29 shows a photoelectric effect experiment. When the intensity of light increases, the reading of ammeter decreases. What is the most appropriate conclusion based on characteristics of the photoelectric effect? Intensity of light affects the number of electron emitted. When more photons collide with the metal, more electrons are emitted, because the photons can collide with more of the, quote unquote, collide with more of the uh, atoms in the metal surface. Thank you. Diagram 24 shows an experiment to show the photoelectric effect on a metal surface with threshold frequency. Light used have different frequencies. Okay. Compare the maximum kinetic energy of photoelectrons released in both equations. Kinetic energy, when max kinetic energy, is equal to the hf minus h f naught, equal to h f minus f naught. So over here, kinetic energy release would be 0 joules, and this would be some other higher joules. Okay, electron. C. Anyways, time to mark one C imperial units. Yes. Question 2, the amount of heat. Question 3, D. Yes. This is infrared sentence. This is the hypothesis. This is the relation. Number 4, B. Yep. Number 5, C. Number 6, B. Yep. And number 7, D. Number 18. 9B and C. I'm just gonna mark silently for a bit. If I get anything wrong, I'll stop again. Excuse me. 15. Okay, I need to uh, what's the name? I should really just open the textbook, but I'm too lazy. And I'm guessing that I won't find it here. Seriously. Nanda equals baseline. Yeah. A equals distance between two coherent wave sources. What? The distance between two coherent wave sources. X equals distance between two adjacent nodal or angular. And D equals equals perpendicular distance between parallel lines and we add here an summation. when given to different coherent sources, and this is A, this is X, and this is B. I guess I shouldn't use this. I do. Okay, good enough. Okay. Moving on. What will we add? PT. No, I haven't marked it. 16 T. Yep. Eighteen D. What expression 18 again? In a regular exam I would draw this, but I don't have a ruler. Well, I do, but I'm not drawing on my PC with a ruler. Or am I? That's okay, I am. Say this is F, this is F. U equals B. Oh, okay. What was the answer? 18A equals to 2F. I need to open the textbook for this one. Physics. Why not have the English version downloaded? That's okay. Open up. Here it is. Why not here? Slightly up. Hmm. Makes sense. The image inside two, the object inside 2S, not at S. So it will be here is 2S, here is 2S, approximately half of here. So it will be something like this. This is the terrible solve. I need my ruler again, chili face. Good enough. Whatever, never mind. I'm not gonna draw it. I doing all that. When TV. The concave view. It's in makeup mirror. Makes sense. Makes sense, makes sense. Am I stupid? This is the right side, not the left side. I think I'm stupid. Right? Is this real? No, not real. These questions definitely true. Okay, so hmm, 15. I need to memorize this. I'm gonna sorry. this because it's disrupting the picture. And extend the D a bit because this doesn't look like a T. D. Question 18, something like that from 18. Yeah, this I would have contained on the natural exam. I would draw it 20. This is an application question. I just need to well, makeup mirror. Okay. And for question 32, I'm just dumb and confused my left and right. Okay, now that's done. I'm going to save this, save this, close, 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 and open paper 2 of, I think it was number, and the marking scheme. Oh, no, no. Okay, this is good enough size. Section A, answer all questions. Diagram 1 shows velocity against time graph for a moving car. Define velocity. Velocity is rate of change of displacement. State the base quantity shown by the graph, time t. State the physical quantity shown by the gradient of the graph. The gradient is in meter per second equals meter per second squared equals acceleration. I am sitting in a terrible position right now. acceleration. Using quantity. The answer on question B2 is a vector quantity. Gives one other example of vector quantity. It's already shown was a fashion velocity. What is this you are talking about?